In special and general relativity, the four-current is the four-dimensional analog of the electric current density, which is used in the geometric context of four-dimensional spacetime, rather than three-dimensional space and time separately. Mathematically, it is a four-vector, and is Lorentz covariant. Analogously, it is possible to have any form of current density, meaning the flow of a quantity per unit time per unit area. See current density for more on this quantity. This article uses the summation convention for indices. See covariance and contravariance of vectors for background on raised and lowered indices, and raising and lowering indices on how to switch between them. Definition: using the Minkowski metric of metric signature, its four components are given by, where c is the speed of light, ρ is the charge density and J the conventional current density. The dummy index alpha labels the space-time dimensions. Motion of charges in space-time. This can also be expressed in terms of the four-velocity by the equation, where ρ is the charge density measured by an observer at rest observing the electric current, and ρ0 the charge density for an observer moving at the speed u along with the charges. Qualitatively, the change in charge density is due to the contracted volume at charge due to Lorentz contraction. Physical interpretation: charges at rest will appear to remain at the same spatial position for some interval of time. When they do move, this corresponds to changes in position, therefore the charges have velocity, and the motion of charge constitutes an electric current. This means that charge density is related to time, while current density is related to space. The four-current unifies charge density and current density in one electromagnetic entity. Continuity equation. In special relativity, the statement of charge conservation is that the Lorentz invariant divergence J is zero, whereas the four-gradient. This is the continuity equation. In general relativity, the continuity equation is written as, where the semicolon represents a covariant derivative. Maxwell's equations. The four-current appears in two equivalent formulations of Maxwell's equations, in terms of the four-potential, whereas the D'Alembert operator, or the electromagnetic field tensor, where μ0 is the permeability of free space. General relativity.